Hello, the Math Dog here. In this video I go over some exercises involving parallel lines and the angles formed by parallel lines. So first of all we'll talk review about corresponding angles. So corresponding angles are formed by, you have two lines that are cut by a transversal. I'm calling that T, the lines are A and B. So I have four pairs of corresponding angles here, angles 1 and 5. Angles 2 and 3, angles 4 and 6, and angles 7 and 8. So like 1 and 5 are in the northwest corner. They're a pair of corresponding angles. 2 and 3 are in the northeast corner. Angles 4 and 6 are in the southwest corner. And angles 7 and 8 are in the southeast corner. As I mentioned here, these are pairs of corresponding angles. Now, for like angle 1 to be congruent to angle 5, the lines have to be parallel. I haven't stated that yet, but we will be doing that in these exercises. We're going to assume A and B are parallel, but right here I'm not making that assumption. So then we have alternate interior angles. We have two lines A and B. They're intersected by a transversal that intersects both lines. The interior is on the inside of these two lines, the exterior is on the outside. Alternate interior angles are on opposite sides of the transversal here, like angles 1 and 2, and they're on the interior. And then angles 3 and 4 are also on the interior, and they're on opposite sides of the transversal. So we have alternate interior angles, angles 1 and 2, angles 3 and 4. So once again, right here I'm not assuming the lines A and B are parallel, but if they are parallel, then we know that the measure angle 1 equals measure angle 2, measure angle 3 equals measure angle 4. So then we had same side interior angles. This is the interior of the two parallel. These lines are not parallel right now. We're just going to say this is the interior, this is the exterior. Same side interior angles are on the interior of the two lines A and B, and are on the same side of the transversal. Now if the A and B are parallel, then we know that the sum of angle 1, the measure of angle 1 and measure angle 2 equals 180 degrees, or in other words, they are supplementary. Same thing for angles 3 and 4. Okay, so now we have our corresponding angles postulate. If lines are parallel, then the corresponding angles are equal. So if I'm giving you that lines A and B are parallel, then we can say the measure angle 1 equals the measure angle 2, and that was by assumption. I did a video on all these proofs and postulates. Then we had the converse of the corresponding angles postulate. If corresponding angles are equal, then the lines are parallel. So if I have lines A and B and you have a pair of corresponding angles that are equal formed by this transversal here, you know that the lines A and B are parallel. And I mentioned before that we can write corresponding angles equal if and only if the lines are parallel. So that's called a biconditional statement. It means if and only if, or IFF. So a biconditional statement means that the statement and its converse are true. So that means instead of having to say two things, lines parallel implies corresponding angles are equal, and corresponding angles are equal then implies lines parallel, I can just make one statement to say corresponding angles are equal if and only if the lines are parallel. Okay, then we have the alternate interior angles theorem. So what that stated was if lines A and B are parallel, then this pair of alternate interior angles will be equal, angles 1 and 2 in this case. Then we have the converse of the alternate interior angles theorem. If two alternate interior angles are equal, then the lines are parallel. So here, measure angle 1 equals measure angle 2, therefore lines A and B are parallel. Once again, we can write a biconditional statement because both the statement and its converse are true. Alternate interior angles are equal if and only if the lines are parallel. Then finally, I talked about in my other video about same side interior angles. So if the lines are parallel, then same side interior angles are supplementary. So here is lines A and B. Here are two same side interior angles. Okay, if the lines are parallel, we know the measure of angle 1 plus measure of angle 2 equals 180. In other words, the angles 1 and 2 are supplementary, which means they add up to 180 degrees. Likewise, if I have a pair of same side interior angles that are, it should say equal here, it doesn't. So it's not actually equal, they should be supplementary. And I did say that here. So same side interior angles are supplementary. In other words, the measure of angle 1 plus measure of angle 2 equals 180. Then I know lines A and B are parallel. And finally, once again, we can write that as a biconditional. Same side triangles are supplementary if and only if the lines are parallel. And remember, that means this can be read both ways. So you could say lines parallel implies that same side interior angles are supplementary. All right, so now let's do some problems. I'll give a couple examples and some practice. So let's assume here that line S and T, both these lines are parallel. This would be a transversal. I didn't name it. Let's just call it M. So this is a transversal, notice, that cuts these two lines, okay, and these lines are parallel. So therefore you have corresponding angles that'll be equal. You'll have same side interior angles that are supplementary, and you have alternate interior angles that are equal also. So notice that B and A are, in fact, that's a pair of same side interior, I'm sorry, those are a pair of alternate interior angles, because this is the interior here between S and T, and these are on opposite sides of transversal. Well, here's a pair of vertical angles here, so A has to be 41 degrees. Therefore, that has to be 41 degrees. So now you have right here, that has to be 180 degrees. So this is 25 and 41. That's 66, okay? So that C has to be 180 minus 66, because all three of these have to add up to 180. So that's 114 degrees. So C is 114 degrees. B is 41 degrees. And A is 41 degrees. Okay, again, checking your work here. 41 plus 114 plus 25 has to equal 180. That's 10, carry a 1. 6 and 2 is 8, 180. Okay, another example. So I have a set of parallel lines here because I'm giving you that X is parallel to Y. Okay, so I've marked it here. They're parallel. Okay, so now let's find all these angle measures. So this is a right angle here. That means this has to be a right angle here. Okay, because they have to be a linear pair there. If this is 40, this is 40. There's all kinds of ways you could do this, but that's C has to be 40 by vertical angles the way I did it here. So that's 40 degrees. Okay, now if these lines are parallel, that means this is a pair of same side interior angles. Well, if that's 90, this has to be 90 because 90 plus 90 is 180. So A has to be 90 degrees. It's a right angle. Okay, now there's all kinds of ways you can figure out B, but I'm going to go, okay, that's a linear pair there. So 40 and 140 equal 180. So B has to be 140. Okay, so now you've got this is a pair of parallel lines, so E, these two angles here have to be congruent because those are alternate interior angles, so E is going to be 40 degrees. I gave B as 140, I already did that. So now this is 90, this is 40, so that's 130. D, so 90 and 40 makes 130, so 180 minus 130 has to equal D, so that's got to be 50. That has to be 50 degrees there because by the triangle sum theorem, these three have to add up to 180. Now there's a linear pair. If this is 50, that has to be 130. So D is 50 degrees, and F has to be 130 degrees. All right? All right, in my last example here, line X is parallel to line Y, and line Y is parallel to line Z. Therefore, X is also parallel to Z. So we can also state this. Okay, so we're going to have a bunch of corresponding angles that are equal. We're going to have a bunch of alternate interior angles that are equal. We're going to have a bunch of same side interior angles that are supplementary here. So let's fill this in. So right off the bat here, these are parallel. This is a transversal here, so these two have to add up to 180. So A has to be 100 degrees because these are same side interior angles. Now 70 and B, these are corresponding angles, okay, so they have to be congruent, so B has to be 70 degrees. Okay, now this is a linear pair here, so this has to be 100 degrees, but also you know it's 100 degrees because these are corresponding angles here. Okay, now here's a pair of same side interior angles. This also has to be 80 degrees, and this also, because of same side interior angles, but also because of corresponding angles. So C is 80 degrees. All right. So then D is the same side interior, is a linear pair with C, so that has to be 100 degrees. D has to be 100 degrees. If that's 40 degrees and this is 100, G has to also be 40 degrees because by the triangle sum theorem, these have to add up to 180. So G is 40 degrees. Okay. All right, so it's a vertical angle right there. So all vertical angles are equal. So H is 70 degrees. And that concludes this problem. Now I want to point out here, you got to be careful here. So these are the transversals here, okay? These are not the parallel lines. So there is a tendency for people to go, okay, well that's got to be, this has to add up to 180 this way. Those are not same side interior angle. Well, they are, but they're not for the parallel lines, okay? These add up to 170. If these purple lines were parallel, then this has to add up to 180, but they're not. So this doesn't have to add up to 180 either. So our parallel lines are here and here. So the transversal, this is the interior. The interiors that we're talking about are going this way here. Okay, so these are same side interior angles that have to be add up to 180. These are same side interior angles that have to be 180 because these are the parallel lines here. These are not. Okay, so please make that distinction and be very careful when you do problems like this. Okay, so now let's do some practice. I want you to stop the video and do the problems, figure out what the measures have to be, and then turn it back on, see if you agree with what I got. And we're assuming M is parallel to N. Okay, so let's do this. So A, well, let's start with something else. We know M is parallel to M. Okay, so right here, angle B, that's a same side. There's different ways you could start this, but the way I'm going to start this is, okay, B is a same side interior angle with this here. So these two have to add up to 180. This is again the interior in here. Okay, same side interior angles. This is your transversal. So that has to be 55 degrees. B has to be 55 degrees. Okay, this is 130 degrees. So C, this is a linear pair. That has to be 50 degrees. Okay, so now this is a triangle here. By triangle sum theorem, these all have to add up to 180. Well, 50 and 55 is 105. 180 minus 105 is 75. So this has to be 75 degrees in here. So A, now we have a pair of vertical angles here. That has to be 75 degrees. Okay, C we said is 50 degrees, okay? So now, again, we have our parallel lines here. So M and N. And this has to be we said A has to be 75. Here's a linear pair. This has to be 55 again. Okay, and notice that here's actually, these also are alternate interior angles. You could have done it that way. Here's a pair of alternate interior angles, this and this. Now, I'm going to use the triangle sum theorem again here. So this is going to be 130 degrees. So that has to be, E has to be 50 degrees. You could also see that here's a pair, here's your transversal, here's your parallel lines, here is a transversal. So this and this have to add up to 180 because they're same side interior angles. So this does take some practice, but as you do more and more of this, you get good at identifying things. So then this is D, this is a linear pair, 50's here, that has to be 130 here. Okay, D has to be 130 degrees, and notice also it's an alternate interior angle with this and this. So that's our conclusion on this problem. Okay, we have one more problem to do. So stop the video when you read the problem. And so we're given that S is parallel to T. You have a couple transversals here. So stop the video, do the problem, and see if you agree with what I got. Okay, so S is parallel to T. Okay, so we know right here this is a linear pair. There's probably different ways. There's different ways you can do this, but that has to be 50 degrees. A has to be 50 because this is a linear pair here and here. They have to be supplementary. So that's 50. Okay, now these are parallel lines right here. So here's a pair of same side triangles. I know that's 130 degrees. So therefore, then here's a pair of vertical angles. C has to be 130 degrees. Okay. Now B is a linear pair with this or this. This has to be 50 degrees, and it also happens to be a corresponding angle. A and B are corresponding angles. So either way you slice it or dice it, B is 50. And then, okay, so if this is 130, this has to be 50 right here because of alternate triangles. Now if this is 28 here, well, there's a bunch of ways you could do this. I'm going to probably do the triangle sum theorem, but so this is 50 and 28, that's 78. So 180 minus 78, okay, that's going to be 102 degrees. So this has to be 102 here. This is a linear pair. This has to be 78 degrees right here. Okay, so that's the way I did it. There's other ways you could do it, but that concludes the video. So I hope this was helpful in getting you to identify the different types of congruent angles when you have parallel lines. Okay, if you found this video informative and you liked it, please give it a thumbs up and consider subscribing to my YouTube channel, The Math Dog. You may share the content of this video with others. Thank you and have a good day.